Exponential functions, growth and decay. So we're going to evaluate some exponential expressions to model growth and decay in this section. So first off, we need to know what an exponential function is. Exponential function is a function that it's modeled by increasing by some factor or decreasing by a factor. So in the example, you can see that it doubles. This is an exponential function, unlike a linear function that increases by a constant or decreases by a constant. Exponential functions form is f of x equals b raised to the x, where x is the exponent and b is the base. A graph of an exponential function will be curved. In this graph, you can see that the range, or the y values, are greater than 0. It never really hits the x-axis. It just gets closer and closer and closer, and then expands up to infinity. Because it does not equal 0 at the x-axis, this would be called an asymptote. Exponential growth will be when I have this function f of x in the form a b of x, again b the base. B is greater than 1, then this is growth. But if it's between 0 and 1, this is decay. You can just look at the b value only, and see if it's growth or decay. So looking at my first example, my b value equals 1.5. It's greater than 1, so this would be growth. You can graph this in Desmos. You don't have to really use a table of values. You can get them after you've graphed it in Desmos. You would find that the y-intercept is at 1. So you plot that point, and you know it gets really close to x and then goes up. If I were to take the table of values, you hit the table function, it will give you these 5, or 4, sorry. And you can just fill in the table. Looking at the next one, I have an a value this time. B is always what is raised to the exponent. So b is 0.8, which is between 0 and 1, or less than 1. So this would be decay. Using our Desmos, putting that in, you would find out that the y-intercept is 30. Decay is going to decline and get really close to the x-axis. So doing the check it out, my b is 1.2, greater than 1. It's growth. Graph in Desmos. Find that the y-intercept was 5. And we need to make it look like it's increasing. So how do I know if it's exponential growth or decay? That b value is greater than 1, it's growth. If it's between 0 and 1, it's decay. A good application of exponential function is a percent increase or decrease, or an appreciation or a depreciation. What determines a growth or decay is this growth or decay factor. When I add my rate, it's a growth factor. When I subtract, it's a decay factor. The generic form is that we write A of t equals our initial amount times 1 plus or minus that rate as a decimal raised to the t power. Okay, in Desmos you can't use t's, you use x's. So let's model the growth for this guitar. It starts out at initial amount of 12,000. It's increasing by 14%, so it's plus, and to the t power. Simplified, it would be 12,000, 1.14 to the t. You would just graph this portion here, raised to the x. So when you graph that, it's going to look something like this. And when I want to predict 60,000, you just start typing in some x values till you get the y to be 60,000. And when you do that, it'll be sometime between 12 to 13 years. Okay, so this you should try on your own. It says population was 350 to start. It's increasing at 14%. When we'll reach about 20,000, and if you graph that, use the table, start typing in values, it will take about 30 years. What does 1 plus r represent? The growth factor. Or growth increase at a constant rate. Depreciation. So this is when it loses value. Cars do that as soon as you drive them off, actually as soon as you sign on the dotted line. So depreciation is going to be a growth decay. So it's going to be the same function that we used, the initial amount. But now it's 1 minus the rate as a decimal raised to the t power. Or if you want to combine those, the graph of the function is It's going to cross over 28,000 and it's going to come down. And we're looking when it will fall below 5,000. Again, you do the same thing. Use Desmos, type in some X values until you see the Y fall below 5,000. One more example. We have a depreciation. It starts at 1,000. Depreciates at 15%. Graphing, what will that look like?
Hollywood is a really strange place where very strange things happen, and this is a glimpse, into that.
It's going to come down.
One way or another, a good push to the brink in terms of
And when does it fall below 100?
Last year's most addictive new reality show is back with all new inmates for 60 days in Atlanta.
Do not fear, for I am with
How does the graph of an exponential function change when r is subtracted from 1 rather than added to 1? It shows a decrease.
Chicago universe just got a little bigger.
And tell how you determine without graphing the function or performing any calculations whether f of x equals 2/3 to the x increases or decreases. The interval doesn't matter. It's the fact that b equals 2/3. It's less than 1. So it will decrease.
episode, I guess, is airing as
And this ends 7-1.